Good morning to all dear students of EX fourth semester. Today I am going to upload. I want to say I am explaining my YouTube video lecture number 2 on the topic demand factor, load factor, and diversity factor in power system. First of all, we should know, or we can say we should be aware about what is demand factor, what is load factor, and diversity factor, and what are their importance. So we will take it one by one these topics, and we will have a numerical example also for better explanation. So we'll start. So I'm going to slide number 1. So first we will see what is demand factor. So demand factor of an electric power station is defined as the ratio of maximum demand on the power station to its connected load. That means demand factor simply means it is a ratio of maximum demand on the power station to its connected load. Okay, generally the value of demand factor is less than 1 because maximum demand on the power station is usually less than the connected load to the power station. We know this fact very well if we sit in a room or we live in a house or home. We will see different types of load connected there, but we will not switch on all the loads simultaneously at a time. That's why the value of demand factor is less than 1. Okay, this is clear because the maximum demand on the power station is usually less than the connected load to the power station. Okay, and hence we can say knowledge of demand factor is important in determining the capacity of equipment of the power plant. Okay. So we'll move to next slide. There is simple example regarding this demand factor. In this question, we will see a generating station has a connected load of 50 megawatt and it is having a maximum demand of 30 megawatt. So we have to determine the demand factor of the power station. So how can we solve this numerical? In this way, maximum demand given is 30 megawatt and connected load is 50 megawatt. So as per our formula for demand factor, it is given as maximum demand divided by connected load. So demand factor equals to 30 megawatt divided by 50 megawatt equals to 0.6. So in this way, we can easily find out the values of demand factor. Now we'll move to next topic. What is load factor? Load factor of a power station is defined as the ratio of average load to the maximum demand on the power station during a given period. That means, what is load factor? Load factor equals to average load divided by maximum demand. Okay, if a power station is in operation for suppose T hours, some hours, 4 hours, 6 hours, we have taken T hours, then the load factor is given by load factor equals to average load multiplied by number of hours, that means T, divided by maximum demand into T. Therefore, load factor equals to total units generated in T hours divided by maximum demand multiplied by T hours. Load factor can be daily load factor, monthly load factor, or annual load factor. That means it can be daily, on day basis, on the month basis, or a year basis. If the time period T considered is a day, or a month, or a year respectively, that means it can be daily, monthly, or yearly. Load factor of a power station is always less than 1. Why? It is because the average load on the power station is smaller than the maximum demand. That means maximum demand will be always higher. What we see? Because average load on the power station is smaller than the maximum demand. That's why we have considered load factor of a power station is always lesser than 1. The load factor is very important because it is used to determine the overall cost per unit generated. if we are interested to find out the overall cost for a single unit generation, then we have to know this load factor, or we can say we should understand the importance of this load factor. That is, if the load factor of the power station is higher, then the cost per unit generated will be lesser. That means higher the load factor, lesser will be the cost of units per generated. A simple example is given for better explanation of this load factor. We will see this numerical. In this, the maximum demand on a power generating plant is 2000 kilowatt. A power generating plant is given where we can say whose maximum demand is 2000 kV kilowatt. If the number of units in kWh generated per year is 5 lakhs, then determine the annual load factor of the plant. A numerical is given, we have to find out the annual load factor. So whatever in solution, we'll see what is given to us. We know load factor of the power station is given by load factor equals to average load divided by maximum demand. Since average load equals to units generated per annum divided by hours in a year. Here, units generated per annum is given as 5 lakhs. So we have taken 5 lakhs here in the numerator divided by number of hours in a year. So 365 into 24, 365 days in a year. So we will multiply this 365 into 24. That will give us 8760. So average load will comes out as 57.078 kW. Hence, we can find out annual load factor, which will be average load divided by maximum demand. So average load is 57.078 divided by 2000. So we will see 0.0285. That means 2.85%. This will be your load factor. So in this way, we can simply find out what's the value of load factor. We will move to next slide now. Diversity factor. What is diversity factor? Diversity factor of the power station is defined as the ratio of sum of individual maximum demand to the maximum demand on the power station. What does it mean? It will be a ratio. Which ratio? Sum of individual maximum demand will be in numerator divided by maximum demand on power station. So we can say diversity factor equals to sum of individual maximum demands divided by maximum demands on the power station. Here, diversity factor of a power station is always greater than 1. This diversity factor plays a vital role, that means very important role in the determination of cost of generation of power. The greater is the diversity factor, the lesser is the cost of generation of power. Higher this value of diversity factor, we will have lesser the cost of generation of power. We will go for a numerical example of this. Example is given. A diesel power plant supplies the following loads to various consumers. Load is given. Domestic light equals to 500 kilowatt. Domestic power equals to 100 kilowatt. Industrial consumers equals to 2000 kilowatt. And commercial establishments equals to 700 kilowatt. If the maximum demand on the power station is 3000 kilowatt, determine the diversity factor of the power plant. So how can we find out? We know diversity factor of a power station is given by sum of individual maximum demands divided by maximum demands on the power station. So we have individual maximum demands here: domestic light, domestic power, industrial consumer, and commercial establishment. We will have to add on all these things. So diversity factor will be equals to what? 500 plus 100 plus 2000 plus 700, which are the data given here. Their sum divided by the maximum demand, which is 300 kilowatt. So this will give us the value of 1.1. That means diversity factor is always greater than 1. We know greater the diversity factor, lesser the cost of generation of the unit. In this way, we will understand, we can think about these topics: diversity factor, load factor, and demand factor. There are so many more definitions are also here. We will see in the later videos. So from here, this is Devin Tiwari from X department. Goodbye to all of you. Hope this will help you in your study. We will meet in next lecture. Thank you very much.